Hello, everyone. So, like we discussed in the previous video, we are going to now look at the demo of the random forest classifier. And if you remember, we discussed the internal mechanics and the advantage of the random forest. And now what we're going to do, we're going to actually run the demo in the DataBricks environment using the random forest classifier. And one thing you're going to find out, it is working in some way better than the logistic regression, but in other way it is performing worse compared to logistic regression. So that's where we're going to see, once we have more than one algorithm, how we can actually combine these algorithms to get the outcome that we can use to predict the final outcome based on the classification of all these algorithm. So let's first look at the random forest classifier, because keep this in your mind that at the end of all these algorithms, we come back and we'll see how we can collect all these outputs, and then we can merge them together to see that what's the most common output, and we can recommend it as a class of our object, right? So let's now move into the dev environment. Let me just share my dev box. All right, so hopefully the zoom size is good, because I'm quite concerned that in a couple of videos the screen zooming was not right, so it was not showing on the screen. By the way, I'm going to actually I'm going to load it on the GitHub, so as you can download this notebook. You already have the data set. We are still using the same data set. You can see in the data set, like we are using the adult data set, and I've already explained in the previous video. So we're gonna skip the introduction part of the data set, and I'm gonna put the link in the job video description, so you can see the information if you are interested or you haven't actually watched the previous video. So let's start from here. We are going to create a temporary table, because we need to convert the values. Like I mentioned, some of the values are coming as a wrong data type, and you can see in here that education number is coming as string, so I have converted into double. Hours per week coming as string, so I have converted into the double, and obviously the age as well, right? I'm replacing the class with the value 1 and 0, because we only have two classes: people who are earning more than 50K and people who are earning equal and less than 50K, right? And then the rest of the attributes will remain as it is. And just to show you how the data look like after conversion. So now you can see there is no error. So that means all the records has been converted, because sometimes we have to do it, because if we have any error, that error pops out once we we run the SQL statement, and then we go and we find out, okay, where the errors are, so we can fix it before we load it back into our data frame. All right. So now you can see I'm just using the same thing like I mentioned. So once the SQL statement is ready for reload into the data frame, so I have my DF adult data vector prepared that I'm going to use to feed into my machine learning model. So let me just load the outcome into this data frame. It's loaded. It's pretty fast here, and let me quickly sense check the data type. So you can see the age is now coming properly in double, education number is coming as double, hours per week coming as double, and then the most important one, class output, is coming as double, because that's what the machine learning algorithm is going to predict. Either it's going to predict as 1 or 0. All right, so just for a sense check, let's display some of the data. And if you remember, I told you that always careful once you are using the display, because it normally try to show all the record. The good thing with DataBricks that it already limit the number of record it actually displays, so you can see click to re-execute with maximum result limit. So by default, it is just truncating with the 1,000 records. I think we are good because we have already gone through with the full exercise that include the feature engineering and that include the data preparation exercise in the previous video. So we don't need to worry about. All we need to see that all the required attributes, especially the vectors that we are going to feed into machine learning, they are present. So we are all good. And just on this confirmation side, we did it in the logistic regression as well. We are just checking, okay, we have 7,841 instance of people who are earning more than 50K, and we have, less than equal to 50K who are earning 24, sorry, we have 24,720 people who are earning less than equal to 50K. And obviously our data set is imbalanced. So we're going to see the impact of that imbalanced data set in our prediction. All right. So just for the confirmation side, we are getting the same number because we have converted the value greater than 50K and less than equal to 50K into numbers. So you can see 0 and 1. So that is matching, which is good now. So we are ready to actually stitch our vectors that we have created together to prepare the feature set that we can feed into our machine learning model with the target column. All right, so these are all the attributes or the columns that are going to stitch together, and we are calling it as a features. And I'm going to transform it. And once it's transformed, I'm going to use that transformed column, which is feature, and with the class output, because that is my target column. And I'm going to just on the safe side, I'm going to count it. It's going to be the sum of these two values. So the sum is coming correctly. So I'm good. Now I'm going to actually prepare the data frame for my machine learning model. So I'm just going to all of the other attributes. Now I'm not interested. I'm only interested in the features and the target variable, right? And just to show you how the data looks like. Actually, that's not a very good representation, because sometimes, it's funny, like it just cut the output out, which is not good. So I'm just going to use the display, right? And let's see what we're gonna get it. So now you can see the output is coming properly. At least you can see the full value, right? And let me just open it up. So you can see we have the length of the feature set is 82. And if you haven't seen my previous video where I described that how the number of feature exponentially increase if we have multiple categorical variable in our data set. So please watch that video. I have already explained how the feature set, increase quickly with the categorical variables, right? So in this case, we have 82 features that we are going to feed into my machine learning model, and I'm going to get the class output, whether the person is going to be earn more than 50K or less than equal to 50K. Now, the next thing before we feed, we call the machine learning model, we are going to split our data set into three sets, obviously training, testing, and validation. And by the way, I'm going to actually explain the cross-validation technique in here in the featured video, that how we can apply CV or multi-fold technique to avoid any overfitting and underfitting, and to test the accuracy of our model against unknown values, right? Especially if we just randomly feed unknown data, how the model is going to behave, that we can see and we can find the accuracy. All right, quickly show you the training data set length. We have 19,000 instances and obviously with 2 columns. All right, so we are all good. Running the class output instance group by, and we're seeing the count. So we have the class output count by the class output. Where class is 0 means people are earning less than equal to 50K. We have 14,000 instances. However, on the other side, we only have 4,761. So we are good. We are going to now that's the most important part. Now we are calling the random forest classifier. And if you remember the class analogy, like if you don't know the internal mechanics of the car, but if you know how to drive the car, you can gain the full benefits of the car, right? So in order to drive the car, you don't need to know the full internal mechanics. And even, in the last video, when we discussed the decision tree, when we discussed the mathematical derivation of the decision tree, if you want to understand all these technical bits, or you are not very good in the math, but if you can, just if you can understand how you are going to call the machine learning model, that's enough for you. The only thing, obviously, at some stage you need more knowledge, because if things are not running according to our expectation, that knowledge will definitely help you. Obviously, especially people who have the mechanical knowledge of the car, they can play with their car by themselves, right? Instead of taking it to the mechanic, and he can open the bonnet and look at the engine and every other thing. Many people, they learn to how to to do small fixes in their engine, or in the performance of their car, right? So that will definitely help you. But if you don't understand, you can still drive the car. So the same way, if you don't understand the internal mechanics, how the random forest classifier is working, you can still benefit completely from the machine learning model, because all you need to actually prepare the data in a right shape, and then you need to feed the data into your model, and it will split the outcome, and then you need to collect that outcome and display to back to the business. And based on the outcome, based on the prediction and the actual value, you can find the error information, and based on that, we can investigate, and we can fix the data, or the input that we are giving to our algorithm to improve the accuracy, right? All right, so the syntax is pretty simple. We are going to call the label column, and then we are going to call the number of trees. And I'm using, let me start with number of trees with 200, right? And I'm going to call the fit method, because that is going to use the training data set. And then it's going to build randomly 200 trees. And then based on the voting scheme that we have seen on the PowerPoint, whatever vote is going to be the maximum from these 200 tree, it's going to classify the record into that class. All right, so let's see what we are going to get. Let me just run it. You can see the Spark is now running. It's going to take a small time, although we have a small data set, but because we are using large number of trees, so the execution time is going to be increased, right? Which is not going to be much. Yeah, you can see it's only take 24, 30, right? So let's see what we are getting as a prediction. So we get the prediction in the training result variable, and now we are going to display the training variable. Sorry, training result variable. And now you can see it has it has feature, it has class output, it has the raw prediction. And then the most important one is on. So you can see the probability and each class. So you can see 51% is going to categorize that it has a zero, it belongs to zero class, and then it has 48% probability that it is belonging to class 1. So you can see that's why it actually predicts 0. Now you can see the probability is quite close. That means that we need to refine our data set in a way that at least the probability is going to be a bit different. And that's where the whole, the improvement comes into the picture. And I tell you one thing, that's where we do a lot of testing, and a lot of a lot of time has been spent just to improve the accuracy, especially in these cases where you can see the difference between two probabilities is not large, right? It's not like you can see in here we only have 3% difference, and the object has been classified as, excuse me, as a as a zero class. It might be the object has the value of class 1. All right. Now let's again, we are now going to, if you remember, we are now going to display the true positive and false positive, and then true negative, and then false negative. If you don't understand this term, please look at the logistic regression video. I have explained this over there, and then obviously we are going to calculate the accuracy based on it. Let's see. So the test starts coming in. We have, so now this is true positive where the prediction is 1 and the actual output is 1. So you can see the accuracy has been dropped. We only got 1607 accurate result, which is bad. And obviously this number is now going to increase, and these are from the logistic regression. So you can see in the random forest tree, we are not getting better result, we are getting even worse result on the true positive side. All right, let me skip this, and now I'm going to see true negative, where, and true negative means where the class value is 0 and it has been predicted as 0. All right, let me run it. Wow, so you can see it has been improved. So from 13,765, the accuracy has been improved. So it goes all the way to 14,451. And if I just divided 14,451, so let me see, we are going to get 97. Wow, that's really great accuracy that we are getting. So if you remember, I told you that we have unbalanced data sets. So the data sets has biased in it, like it has more data from class 0. So that's why you can see the outcome or the prediction accuracy is leaning towards the class 0, or people who are earning less than equal to 50,000. It is predicting more accurately to that class instead of the other class. So obviously we need to balance the data set, or we need to at least get more data on the other instance, and you will see. But I believe you can see that if we increase the other side of the data, we can balance our data set. So that means we can get really good accuracy with random forest. And we haven't used we only use 200 trees, right? We're gonna see if we can increase that trees number of trees, whether it's going to impact on the accuracy of the outcome or not. All right, so let me just quickly show you the false negative. So where we have the prediction coming as 1, but the class output coming as 0. And if you remember, with that high number in here, the prediction difference is not a lot. Remember that prediction is, it's not quite a lot. It's just more like, maybe the predictions are going to be very close to each other. And how we can see it, that, what I'm going to do, just to discuss it a little bit further to see. I'm not going to actually count it. I'm just going to display, right, the false positive. So you can see the prediction is, in some instances, the prediction is not very different, right? So in these cases, we can understand. So that's where the prediction difference is high. So the probability difference between two prediction is high. But in some cases, if I actually look into it, especially with these one where the one prediction is 55, the other one is 44. So that's not a big difference, 58 and 41. So that means we can improve the data, right? So because for somehow there is something in the data set that is actually imbalancing or impacting on on the predicting of our random forest trees. So that's another exercise that we can do to find out what is impacting on the accuracy of our prediction. And by the way, these are the actual exercise we normally do in day-to-day life. Once we have the real data set, we keep adding data. We just look at the accuracy and we keep improving the algorithm, because every day we get new and new examples or new and new records. So that will either improve or sometime decrease the accuracy. So we find out the balance, how we can, find the factor that is impacting on the accuracy of the data, so we can adjust them, and we can continuously improve the prediction accuracy. And like I mentioned, it never ever going to be close to 100%. It's completely unrealistic, especially with the real data set, because we have a lot of issue in collecting the quality data in our day-to-day life. So that's where we obviously stick to I would say 85 to 95% accuracy. We try to target, it really depends what business is actually giving you as a acceptance threshold to accept your predictions. Okay, so now what we are going to do, we are not going to run the testing data set. What I'm going to do, I'm just going to increase the number of trees just to show you whether it's going to impact on the performance of the tree or not. Let's see. Because we have increased the number of trees, so we're going to see whether the output is going to come in. And right now we know that our class 1 has a problem. Our true positive is coming really low. So we'll just check the impact of increasing the number of trees on that class. You can see the time is slowly increasing, because obviously we have increased the number of trees. All right, so it's done. You can see the time had increased almost double. It will jump up to 44 seconds, but that's still handsome. And by the way, in the real environment, we normally won't have the one cluster. We're gonna have more than one. One node cluster. We're gonna have more than one nodes in a cluster. So you don't need to worry about the timing of running the algorithm. All right, so let's see the accuracy. So we are going to see whether our true positive is going to increase or not. Unfortunately, our true positive is not going to increase by increasing the number. So there are multiple methods that we can use to find out the culprit which is impacting, yeah, 3135, so it's not increasing. What I'm going to do now, I'm just going to do one more thing. As an extreme, I'm going to run it for 1000 tree. And then I'm going to actually run all the way, because like I mentioned, we have other techniques that we can use to find out which one is impacting on the accuracy of our attribute. But obviously that requires some additional coding. We need to actually find the combination of attributes which are giving us the best outcome, right? And by saying it, you might understand that how we can do it. There are multiple. I'll see if I can actually write the notebook where we can see the impact of shifting the attributes, or changing the attributes to see the impact on the accuracy. So hopefully it won't take more than 1.5 minutes. So let's target almost, I would say, 90 seconds. Yeah, 1.26, right? So it's still reasonable. Let's see. Class output 0. what I can do. Yeah, then let's do it. Display trainings. So feature. Yeah, we'll see how we can, handle it later. Yeah, let's see whether it's going to be improved or not. So now we are checking, so hopefully. Yeah, now you can see now the accuracy is decreasing. So it might be having, so that's why I mentioned that we need to find the sweet spot. That means if we allocate 1000 tree, it's not going to increase the outcome, it's going to decrease the accuracy of our tree. So let's take, we already know that one issue we find out the imbalance of the data set, which is impacting greatly on the prediction of our random forest algorithm. So that means to around 200 or 250 trees, they were giving us really good output with this this size of data set. Because afterwards the accuracy is not improving, it is decreasing. All right, let's see. And now just looking at the true negative, which I do believe is going to be better. Yeah, 14,462. And how many records we have? Let's see what we are going to, what's the accuracy we are going to get on our true negative. 14,462. Yeah. So we are continuously improving because I think I put a wrong value previously. We have 890 records. So 10 records were missing previously. And now you can see our prediction is slowly improving. And that's why I say, so you're not going to get, like a big jump into your accuracy once you run against the real life. But a very small accuracy play a very critical role in your business. So we normally improve the accuracy in decimal places, or sometimes we just improve it in the digits as well. Like in here, you have seen that in logistic regression, we are getting around, I think, 87. And with the random forest, the accuracy has been jumped all the way to the 97% for the true negative records. All right. So now we are going to see the result on our testing data sets. So we are ready. Let's evaluate our testing data set because that's the data set now we are going to use to evaluate the accuracy of our model. So now let's see how many records we have because it's only at 20% of the earth. So we have 4,906 for class 0, and then we have 1,527, right? Which is 1/3 of the 0. So let's run it. Let's just displaying the data sets. Okay, so I think we have already evaluate the data set against our model that we have built. So let's see. Now you can see we are getting 525 out of 1527, which is 525 divided by 1527, which is 34%. So that means it is random forest is working very bad against the small data set, or I would say imbalanced classes, right? Sorry, imbalanced data sets. So you can see the accuracy has been dropped to 34%. So logistic regression is working better in against the small data set, but random forest is not. All right, let's see let me just take these ones out because it might just confuse you. And obviously the true false positive is going to be higher in this case. And you can see almost 1,000 two records are coming as a false positive. Let's see what we are going to get are going to get as a true negative. So we're getting 4,776. And we have the total number of records, 4,906. So four nine zero six. All right. 4776 divided by 4906. And we are getting exactly the same 97 accuracy, 97% accuracy. I think it's 97.35. All right. Which is great because that means our model is not overfit with our training set. Like we are just running a completely new data set and the model is still behaving in the same way like it behaves against the training data set. So we only identify one issue, which is obviously with the true positive, that we need to find the reason. And like I mentioned, one of the main reason that I can see straight by looking at the number of records available against each classes. Obviously, the data set is not balanced. The balance of the data set is disturbed. That's why it is impacting straight away on the outcome of the information. But don't worry, we still have a couple of more algorithms in our pocket that will see whether it can take us even one step further compared to this accuracy. All right, the rest is quite clear. I think that's going to be now 7.23 because 370. That's where we are checking the false negative, right? So where the prediction is 1 and but the class output is 0. If you don't understand, please watch again. I mentioned that I've already discussed this area into logistic regression. That's why I'm comfortably going to against each cell, because I understand that you have already seen these cells in the previous demo, right? But if you haven't watched it, I'm going to actually put the link in the description. Please watch the logistic regression demo video where I explain the true positive, true negative, false positive, true negative, and false negative. And then I've already explained why we normally calculate them and what are the matrices we're going to actually calculate based on these 4 factors. Now that is coming now. So we are going to see the information that I just mentioned: TP true positive, TN true negative, FP false positive, and FN false negative. Anyone, you can see the record number of incorrect negative or false negative is very low now, only 130 out of 4,906 records. So it's the random forest is working really great against the balanced classes, sorry, balanced data set. All right, let it be finished and then we'll see. Yeah, so let's see. So like I mentioned, the accuracy, how we calculate the true positive plus true negative divided by the total training result count, right? So you can see the accuracy is still above 80% and the sorry 82%, because if we are going to round it to the 2 digit, so you can, so 82% is not a bad accuracy of your model. Plus you understand that where the issue is. So once you start improving it, it might quickly jump towards the 90% accuracy, which is I would say a very good accuracy if you can achieve in your production or real-time environment. And now let's see the record, which is obviously the relation of the total positive result, the percentage of the total positive from the total positive observation. And now you can see that's the culprit that is impacting on our accuracy. And obviously, as soon as we start improving this figure, that's going to improve the accuracy of our data. All right. So now let's see the precision, which is obviously the percentage of total negative from the total true negative from total negative observation. So you can see we are getting 97%. So these two are actually contributing together to increase the accuracy to 82%, which we can, like I mentioned, we can improve it if we can improve this culprit. Same way, we're now going to actually check before we close the video, we're going to check the testing accuracy. Sorry, I think I've already done it. These cells duplicate for somehow. Okay, let me quickly scroll down. I'm just going to start. Yeah, I think that so it's the same thing, it's the same variables, but now we are checking the accuracy and recall and precision for our testing data set. So let's run it. It would be quicker to compare to training data set because we have a small data set, which is only 20%. Let me run the accuracy cell as well. So you can see our testing accuracy even has been improved to 82.4%, right? So even the unknown data set, our model is performing better than the training set, which is obviously a very positive sign. If we build a machine learning system which perform better with the test data, so that means it's going to actually perform better with the unknown data set because it is not overfit with our training data set. All right, so let's see what the recall. Recall is going to be 34.38, which is better than the training. And let me see, the precision is going to be 97.35%. So that's the random forest demo. It will give you a lot of idea about the real life scenario in the machine learning and the data science environment, what kind of challenges we face once we build the model, and what kind of work is expected from us once we build this model, and then business is expecting a better outcome from our model. So what are the areas that we can normally look into it? And we haven't actually improved this model, but at least it gives you the idea how you can actually find the areas which are challenging and how you can actually think to improve them. So as usual, I believe this video will be very helpful for you to understand the random forest. Please put any comment if you have any question, more than happy to answer. Otherwise, like the video, and in the next one, we're gonna see the knife-based algorithm, which is another classification algorithm. Thanks for watching, and I'm gonna see you in the next one.